All right, the last part of your twin. Uh, First one on 14, find the inverse of 4x plus 8y equals 16. I literally have the instructions for you. Exchange x and y and then resolve for y. It's so easy. So easy, SpongeBob could do it. So I'm swapping these two's position. 4y plus 8x is 16. Now I'm going to resolve for y. I'm going to subtract 8x because I can do that. That's easy. That'll be negative 8x plus 16. I'm going to divide out my 4, and this one will be done. So this will be y equals negative 2x plus 4. Now, choose a correct diagram that has graph 4x plus 8y equals 16. Its inverse and the line of symmetry, which is y equals x. It ought to be an easy problem. It ought to be. Doesn't mean it will be. But, okay, so look at this guy right here. You see this guy right here? This is y equals negative x. Don't be that kid. It ain't b. You see this guy, well, actually, so let's find all of the rest of them actually have graphed y equals x because y equals x crosses through the origin. It has a slope of 1, and every 7th grader is supposed to know what it looks like. The fact that you don't know what it looks like speaks volumes about yourself. It really does. Now, let's look at our inverse here. It is negative 2x plus 4. So we're looking for a line that has a y-intercept of 4. And if you look at this graph, none of these guys have a y-intercept of 4. So gone. All right. This one's a keeper, that one's a keeper. The slope is negative 2. This guy has a slope of positive 2. See how it's going uphill? All these guys have uphill slope. Choice C. And I didn't even have to find the equation of the original one. I could have, and I'll verify it here, but this is my original equation. And I'll play the isolation game here. Divide out my 8 now. The original line had a y-intercept of 2, and it had a downhill slope. Fell 1, ran 2. So everything matches about this graph. It's a really easy problem. It's got a slight mixture of Algebra 2, and then it's 7th and 8th grade math. Find the inverse of this guy. Of course, the instructions are on the previous problem, but you swap x and y, and you resolve for y. And then you use the correct notation. The correct notation here being the inverse of f of x. So let's do our swap. This y becomes an x. This x becomes a y. Now we're going to do easy baby steps. We're going to add 3 to both sides. The opposite of a square root is a square, unless you've been living under a rock. That's supposed to be a 3 there. It's a really bad 3. If you're going to square something, you have to write it twice. We have talked about that repetitively, and yet you still don't want to write it twice. On the right-hand side, the understood 2 and your power of 2 cancel each other out. And then, of course, on the left-hand side, you're going to have to FOIL. You know, if you can't FOIL, x squared plus 3x plus 3x plus 9 is y plus 2. And let's just get that 2 over. We're going to have 6x plus 7. And, you know, I may have taken this too far. I might have. I may have taken this too far. A good stopping point would be this. This is a good stopping point. It's pretty common to leave things in vertex form. So x plus 3 squared equals y plus 2. And that gives me x plus 3 squared minus 2 is y, which of course I use or write as the inverse of f of x. So I don't think I would do this. Focus on this. It's just early and I hadn't woken up, but that's a pretty good way, and that's what we usually do. Usually leave these things in vertex form because with vertex form we can graph quickly. Sorry I took it so far. 16, find the inverse of this one. See how this guy's in vertex form? If you have no idea what vertex form is, start paying attention. Same steps as last time. We're going to swap x and y. Now this is y. G of x is just a fancy way of saying y, and it's going to become x. Every x I see is going to become a y. We're just going to do our baby steps. We're going to subtract 4. The opposite of multiplication is division, so we're going to divide both sides by 2. The opposite of a square is a square root. We're not going to do anything with that expression on the left-hand side. We're just going to leave it like that. So the square root of x minus 4 over 2 is y minus 2. And all we got to do is add 2. The root of x minus 4 over 2 plus 2 is the inverse of f of x. And this one would actually not be titled f because I think it was called g, wasn't it? It would be g to the negative first of x. All right, 17, which is the last one. Identify the real zero. And it says, hey, you know your graphing calculator can do that part if you can't algebra. And it can. And I'll show you. Because it can. What we're going to do is we're going to isolate this guy, which is a half power. We always isolate the exponents. So I have subtracted 5 from both sides. Now the opposite of a 1/2 power, which happens to be the square root power, by the way. Remember that x to the 1/2 is the square root of x. So I'm squaring both sides. All right, so I've got x minus 5 squared. I'm going to write that thing twice. Equals 3x minus 11. Go ahead and do a little foiling on the left-hand side. That's x squared minus 10x plus 25 equals 3x minus 11. We're going to set a quadratic equal to 0. So negative 10 minus 3 is negative 13x. 25 minus 11 is going to be plus 14. And will that factor? You bet your bottom dollar it'll factor. Factors of 14 and add to 13 are going to be negative 14 and positive 1. Using ZPP, x is 14 or x is negative 1. Now, which one works? So it says identify the extraneous solution. Of course, this part was identify the real solution. So if I go back to the original equation and I put a 14 in, this is going to have a 14 on the left. Question is, does that equal what happens if I put a 14 on the right? So the right-hand side would be 5 plus 3 times 14 minus 11 to the 1/2 power, which is the square root. So 3 times 14 is what? 42, right? Seems right. And 42 minus 11 is 31. So is 14 equal to 5 plus the square root of 31? No, it's not. So the extraneous answer was 14. That's the extra one. The real one was negative 1. So let's see what happens if, or was it? Interesting. Well, I made a mistake somewhere. Yes, I am tired. Let me pause this. I feel like I've made a mistake somewhere. I did make a big fat mistake. It's right here. Hopefully you were watching and you figured that out. But yeah, I made a big mistake and I wasted part of your life there. I'm sorry about that. But it just didn't feel right. 25 plus 11 is 36. Now, there are still factors of 36 that get us to 13. It's amazing that I made a mistake and it still factored. Wouldn't have expected that to happen, but it does happen. All right, so factors of 36 are going to be 9 and 4. To add to a negative 13, they're both negative, and a negative times negative is positive, so there you go. So let's try these. By zero product property, x is 4 or 9. So let's go back to the original. I plug in a 4. The left-hand side is 4. The right-hand side is 5 plus 3 times 4, which is 12, minus 11, and the half power is the square root. And I get 4 equals 5 plus the square root of 1, which is 4 equals 6. No. So that one's probably false. All right, but let's check my work here. Make sure at least one of these works. I plug in a 9. 9 equals 5 plus the square root. 3 times 9 is 27. 27 minus 11 is 16. And this is going to work because the square root of 16 is 4. All right, so my real solution is x equals 9. My extraneous solution is x equals 4. Now, I mentioned that, you can do part 1 in a calculator if you can't do algebra. Of course, the whole point of this class, though, is to kind of learn how to do algebra, right? I think so. Honestly, the whole point of this class is to make sure that you learn enough algebra to do well in college algebra. That's kind of what the goal is, kids. Let's see here. So the right-hand side, I believe, was x. And the left-hand side was 3x minus 11 to the 1/2. So rooftop that bad boy to the 1/2 power. Zoom 6 it the way you were trained. And you'll see your y equals x, which you should know what that looks like. And the next thing you're going to see is the arm. You see here, there's the arm. Oh, I forgot it was x minus 5. Man, I'm struggling today, aren't I? No, it was 5 plus. The struggle is real. Second insert, 5 plus. Hope I figure this out by first period, or I'm going to be in trouble if I don't wake up. All right, so here's my answer right there. Second, trace 5. And hit that magic enter key 3 times. Once, twice, thrice. Well, first off, I got to see my cursor. There we go. Enter, enter. Took it a minute. So let me go through then what happened here, okay? Let me go through the whole process again. The cursor wasn't showing up, so the calculator was stuck in like this infinite loop of not being able to do anything. So I had hit second trace 5, and I pressed enter, but the cursor didn't jump. But see, it's on red. You can just hold that right arrow until you see it, or you can play with the up and down arrows. It's up to you. Once you see your cursor, though, enter, enter. There's your intersection 9, which, if you can count, you could have kind of looked and glanced down and seen that it was a valid answer. You could have. Anyways, I believe that is it. So, good luck on your little test.